Below we have the edges of 19 randomly chosen students, and we want to summarize the data graphically, and we are told to use a box plot. So we remember the box plots look like that. Maybe you're not too sure what these dots mean. And we also know that it's somehow obtained from the 5-number summary. Therefore, the first thing we need to do is to explain how exactly we get the box plot from the 5-number summary. So, there is a box, and inside the box there is a bar. This bar is the median. It's not the mean. You need to find the median. Now, the edges of the box are the first quartile and the third quartile. The difficulty is what goes at the end of the whiskers. It's not those values. It really is the smallest value between Q1 and that, and the largest value between Q3 and this. In other words, it has to be a value in your data set. So let's do it. We start with the box. So the median is 20, that goes at the center of the box. Then 19 is the first quartile, and 22.5 is the third quartile. The height of the box is only for aesthetic reasons. I'm just going one square up. So that's the box. Now the whiskers. So we calculated these numbers earlier. This is 13.75, and this one is 27.75. The end of the lower whisker will be the smallest observation between 13.75 and 19. So 13.75 would be somewhere there. So the smallest observation right above that is 18. So this is how we get this whisker. Now on the other side, we want the largest observation between 22.5, so there, and 27.5, and that's inclusive. Well, 27.75 is not on our list, so the highest we can have is 25, and that's the end of the upper whisker. A very important thing to notice is that this is not 27.75, and this one is not 13.75. We actually have to use one value in our data set that fits between these limits. Now, in case you're wondering what the little circles were, they're the outliers. So we said earlier that there was only one outlier, and it's 29, so we represent it with a little circle. And this is it to get our box plot. It's very useful to do it by hand at least once to just get a very clear understanding of what each element in the box plot is. Now, in practice, you really don't do it by hand. So we can answer the same question using the software R. As usual, combine all your numbers into one object, which as usual I've called age. And you can say, I want a box plot of age. Actually, box plot of age would be enough. I wanted it to be horizontal just so it would fit on the page. And this call stands for color. I can decide what color I want. And you can see that the end of the upper whisker is 25. We get this 18 again. And that's our outlier at 29. Just a word of caution about the boxplot terminology. Maybe you've seen in the past something called boxplot, and the end of the whiskers with the minimum and the maximum. The textbooks call those one boxplots, and they called modified boxplots, the one which used the 1.5 interquartile range rule. Well, for us, those are boxplots. So in this course, whenever we mean boxplot, just like R, we will mean that we're using the 1.5 interquartile rule, and that we want the outliers represented by these little circles. Choosing one definition or another really makes a difference. This is the same data we had earlier. You'll recognize our outlier at 29, and this is the shape of the box plot if you use the 1.5 times interquartile range rule for the whiskers, whereas if you use the max and min, then this whisker will look very different. Now, the width of the box is unimportant.